Hello, everyone. I'm Andy Lin with Mark III Systems, VP of Strategy and Innovation. Thank you for joining today's webinar. Today's webinar is all around the introduction of the NVIDIA DGX A100, which is NVIDIA's new flagship AI platform that was announced last week at GTC Digital by CEO Jensen Huang last Thursday. The A100 is a platform that we're all extremely excited about, and just because of its versatility on what it can do, not only for AI training and inferencing, but also analytics, accelerated databases, and really the whole 9 yards about bringing together anything that could be accelerated onto one platform. With us today, we have Will Vick. Will will be our guest presenter today. I'll do a brief introduction of Will before I turn it over to him for today's session. Just a couple real quick housekeeping items. There is a Q&A button at the bottom of the webinar. So if you have questions, please feel free to put them in the box. And then I'll take a look at them and I'll make sure I ask Will during the session if that makes sense. Also, if you have your friendly Mark III contact as well, feel free to reach out to them for questions. Many of them are on the session as well and can help facilitate that. So with that, I'm pleased to be joined by Will Vick today. Will is head of DGX and data center sales for the Americas for NVIDIA. Will has a really long history, AI, but HPC spanning 10 plus years, which he can talk a little bit about. But definitely a really, really strong and knowledgeable person based in Houston, Texas as well. So with that, I wanted to kind of turn it over to Will. Will?
Awesome. Thank you, Andy. And thank you, everybody, for joining today. So yeah, my name is Will Vick. I'm head of DGX and AI data center solutions within the Americas within NVIDIA. Been here for probably a year and a half and took over the DGX sales, for the Americas. And previously, as Andy mentioned, I worked in HPC for years within HPE, and really, now taking a more in-depth approach, from an AI perspective and how we, deliver solutions to customers, specifically with DGX A100. And a lot of the benefits that Andy spoke about as well. It's a lot more versatile than that we've seen in the past. Typically, as we see V100s in the past, typically been, either your training workhorse, for, any of the deep neural networks, analytics use cases as well, but now really kind of bridging, a lot of the major components from a delivery perspective. A lot of it's due to the new GPU architecture, which I'll talk about, but as well, the new system and how we designed it around the GPU architecture. So with that said, DGX A100, just launched as of last Thursday. And a lot of insights associated, with this system and GPU architecture. I don't know if anyone had the chance to see the launch presentation that was on NVIDIA's YouTube channel last week, but really went through a lot of key details of where NVIDIA is, putting dollars for innovation, but as well, how we're helping facilitate AI and helping making that easier for enterprises that are looking to deploy today. And typically, the kind of existential threat and opportunity, for every enterprise is kind of looking at a couple things. Excuse me. Every business is looking to AI. It's on every CIO's docket for the year of how they're going to hit these growth objectives and how they can utilize AI. About 84% of surveyed executives fear missing their growth objectives if they don't scale AI. Secondly, 76% cited their struggle with how to scale AI across their business, because typically, when you're going through this motion with AI, you're looking for one, how do I, start looking at different use cases within my business and how do I approach those to create efficiencies? And really kind of going through ideation workshops to as well, feasibility studies really do help understand where the low-hanging fruit is to really start executing on. And so with that said, when you start highlighting these, ways that, let's say, one, you're trying to, tackle this low-hanging fruit, basically it's a lot of creativity. Data scientists and researchers are very much creative in how you solve problems, and being able to use computing technology today is really where you take that inspiration, which you're iterating to the best model, or fastest time to the solution for every training run, to really get to production. Production always looks as your inference model, where it's imaged, whether it's on the edge within the data center, and how you approach these different layers while maintaining, let's say, cybersecurity trust within your environment. And so a lot of pieces fall to how do I implement these, and how do I scale the efficiencies that I require. Typically what we've seen in the past is kind of this inflexibility of AI infrastructure. And what that means is, typically, like I stated before, the V100's typically been pitted towards your training cluster and or analytics cluster. And inference was not as performant as most people would want to expect, especially if you're looking at a dual socket CPU server versus say a V100 from that perspective. And so therefore NVIDIA came out with things like T4 for separating these use cases. But as well, you have your separate analytics cluster, and also maybe HPC applications that need to be run, to test things out and see what they can provide at scale. So again, having all these separated really does cause, I'd say, a utilization issue where it may be spiky on, training one day, where you may need to train overnight to have your new inference model ready by the morning that's ported to a different system, where analytics, you're doing maybe location-based discovery, ML-based techniques to really kind of, bridge the whole gap of what your business is trying to strive from an efficiency standpoint. So with that said, you start coming out with all these, say, different types of systems with different architectures deployed within a data center, right? And you start having a, let's say, proliferation of different system architectures that are maintained in different ways. And so really what you start looking at, even from an example here, is where you may have, from a training cluster point of view, 6 million in servers and 5 racks, or 5 million in servers and 20 racks for inference, or graph analytics cluster where you're running, $15 million in servers and 105 racks. Typically that's been on a dual socket CPU based server when you're looking at scale based use cases. But really, what we strived with the A100 and DGX in general was trying to create a better platform for AI to help encompass all these needs. And so again, enterprise needed a better platform for AI. And how do we get there and be able to have all this talent that we can utilize to help solve problems faster, best tools for all the jobs, breakthrough performance, to iterate faster on the toughest AI model challenges, to effortless scalability. And so you can again democratize access to every line of business within an organization. And typically what we see customers start with is creating an AI COE, Center of Excellence, where again you can start building out these clusters for R&D, but also start hosting production-based inference to, from a POC perspective, to help understand all this low-hanging fruit that I identified as options. How do I now ensure that from a POC standpoint this grows into a full production workload? And so the DGX system, and what we call DGX A100, is this kind of universal AI system, one system for every AI workload. And really just helping with, yes, the performance, we're getting 5 petaflops, but being able to have, let's say, unmatched data center scalability by sharing out resources effectively, and really being able to help these lines of business and everybody that needs a GPU to get their work done do that without having to worry about all the plumbing in the background. So with that said, DGX A100 is really kind of the one system that we call for all AI infrastructure. And it's a single universal, let's say, building block for building these systems out for AI, inference, and analytics. A lot of this comes down to new capabilities that we've built within the GPU itself, and being able to host these up to, from an operator point of view, from the end user to provision the resources as needed on the fly. So really some new best of breed benefits from a bleeding edge standpoint of how you help accomplish this today. So when you look at today's AI data center, this is a general example where you may have, let's say, 50 DGX systems for AI training, which was DGX1 was an 8-way V100 based system, or even P100 depending if you go all the way back to 2016. But when you look at all this infrastructure, it's roughly $11 million, 25 racks, 630 kilowatts. It's a lot of power, to help associate with the performance, but all having these let's say disaggregated systems and not any kind of uniformity to help with utilization really does kind of bog down the TCO and ROI that you would see. So DGX A100 data center, basically you think about the performance characteristics I was talking about, but as well consolidating here, you're now looking at roughly $1 million for one rack, and 28 kilowatts, versus, let's say, those previous notions of having up to 105 racks in some scenarios. The performance here is dramatic, which helps with consolidation, but also when you're thinking about deploying, helps with reduction of power and how it's utilized in the data center overall. And so when you're looking at scale, these are perfect building blocks on how you do that, and I'll talk about why. And I'll talk about the performance, the innovation that we've done from the GPU itself all the way up, through the stack of how we're supporting this out in the field. So with that, game-changing performance for innovators. What does that mean? So now with the DGX system, we're at now 5 petaflops of AI performance. DGX2, which is our previous version that had 16 V100s, was 2 petaflops, and DGX1 was a single petaflop. So a lot of performance coming out of the system, and a lot of reasons why we built the system to be the way it is. For example, the new NVIDIA A100 GPUs by default are PCIe Gen 4, and we wanted to ensure that all of our customers got the best performance that they could get out of these GPUs today versus later. So we're typically CPU agnostic as a whole, and being able to facilitate this today really is by leveraging AMD Rome-based CPUs within the system. So we have these 64-core version per socket within the system. It's a dual socket system where you're now getting up to 128 cores and comes with a terabyte of memory. And you actually can expand that memory to 2 terabytes if needed, depending on how many, let's say, users you would support within the system as well. There's some really cool technology that we've done with the A100 specifically about, actually having the ability to create hardware GPU partitions to help serve these instances for smaller jobs or different jobs of different sizes to really help support these deployments. And a lot of that really comes down to how much throughput do I have. So again, PCIe Gen 4 helps double that over PCIe Gen 3. And for example, when you look at the way that we architected the system, we now have up to 8 of these MELLANOX, what we call the MELLANOX CX6 200 gigabit per second network interface cards dedicated within the GPU complex. And so therefore you would have 1-to-1 correlation of this 200 gigabit NIC and the GPU itself to ensure that you have a large pipe for, let's say, if you're taking these GPU partitions and serving it out to multiple users. So if you're adding new data or you're running a production-based data set on one of these partitions, again, you would have the ability to run users concurrently, but as well provide enough throughput to support these types of deployments. secondarily, when we look at this, there's a ninth card there, which is typically for your storage subsystem, whether it's a NAS or parallel file system today that you can utilize to connect these all up for fast training and fast inference and performance characteristics if you're looking to drive. And so they're actually, I'll talk about this on the next slide as well, which we go in a little more specs, but the 10th slot there is a 10th slot within the system to expand for additional I/O. And so again, these CX6s that we are using within this are what MELLANOX calls VPI. So being able to run either IB or Ethernet within the node and supporting pre-existing protocols that may be existing in your environment today. So being able to utilize this with minimal change to what you're building or what you have today within the data center. So again, a lot of capabilities here. Each A100 now has 40 gigabytes of high bandwidth memory. So total within the system, you're looking at 320 gigabytes that can be used for a single job or being able to broke down into these partitions I'm talking about. But as well from a storage caching perspective, it comes with 15 terabytes of NVMe Gen 4 SSDs, where you can actually expand that with 4 additional NVMe drives to get up to 30 terabytes total within the system. So a lot of data caching, but as well a lot of performance enhancements, with PCIe Gen 4 from a throughput perspective to really take advantage of the A100. And so that's where this DGX comes into play. Yeah, it's performance, but as well you can start serving this out to multiple users, and I'll talk about why and how this is achieved. So if I move on to the next slide, these are kind of our specifications for the system as a whole. Compared to our DGX2 in the past, that was a 10U, 10 kilowatt platform with 16 V100s within it. That was a dual socket system. And now we're at 6U with this system and 35% less power, where you're now at 6.5 kW max within the system, but you're now achieving 2.5 times the performance of a DGX2 with less GPUs and less power. And so being able to help facilitate this performance and be able to help increase, things like inference performance on the DGX A100 really comes to the new A100 GPU complex and how it's, really, supporting a lot of performance for AI, but as well for inference and other characteristics as well I'll talk about. But again, remember that the system, again, is about 2.5 times, the most performant system in the market today, which was a DGX2 with 35% less power and 50% less cost. So really being able to provide these benefits as well. If you compare this to a DGX1, which is an 8-wave based SXN2 system, you're now looking at 5x the performance as well. So a lot of capabilities here and a lot of ways that you can go and carve these systems up, and I'll get to these details on the next few slides. So, for example, by default and de facto, let's say, measurement of performance out there today is using single precision. So now with peak performance, with the new with the new A100 GPU that's out there versus Volta, you're now getting a 20x performance increase. So you're now up to roughly 312 teraflops. From an inference standpoint, it's roughly 1200 tera ops. So that's a 20x increase over Volta. So this is, for example, one of these is, 7 times as performant as a single T4 from an inference point of view. One of these slices itself that I'll talk about as a partition, is now, let's say 1 times faster than a current T4 today, and I'll talk about that too. So even from an HPC standpoint, for dual precision, we're getting about 2.5x there, and that's always dependent on the application. So things like molecular dynamics, we might see 1.9x increase in performance, where other things you may see up to 2.5. So again, very much dependent on the application. Same thing when you look at FP32 and training different neural networks that are out in the market today. So some of the componentry that really helps with the performance as well is what we call NVSWITCH. There are now 12 NV links per A100 within the system. So that's twice as many as we had within the V100. What this means is now you're getting 600 gigabytes per second of peer-to-peer or GPU-to-GPU communication within the system, and really accelerating these jobs that are being placed upon it. So with that said, you know, the NVSWITCH is what actually helps create this full connectivity amongst all 8 of the GPUs within it. So now you're getting roughly 4.8 terabytes per second bidirectional bandwidth. So in a example here, in 1 second, we could transfer 426 hours of high definition video. So a lot of performance here to help with these really large workloads and large data sets that are associated, but as well, you know, just looking at, you know, how you can approach this from a deployment standpoint really comes down to, you know, different applications that are supported and deployed within the system. So one thing that we did do that was very interesting, so we talked about FP32 as kind of being the de facto training benchmark that's out there today for AI in particular. We now have what is called TF32. So it's a new format for Tensor, you know, for the Tensor cores on the A100. So by default, TF32 is enabled in PyTorch, TensorFlow, and MXNet is coming soon. So what this allows you to do with no code change at all is achieve up to 20x that of the Volta FP32. So getting 20x the performance with 312 teraflops. And that's, again, in use of sparsity. And so we're also supporting sparsity within the new A100 line, which has been a gap for all accelerators within the market. And I was actually at a conference in Toronto where I saw Jeffrey Hinton speak, who's one of the fathers of AI, really was talking about, you know, the gap and the need for sparsity support within accelerators today. And so lo and behold, you know, we are already working on this to have this available this year to really help accelerate this, because at the end of the day, when you're thinking about sparsity and, you know, sparse matrix multiplications, and you have a null value of 0, you know, a null value there, then anything times 0 is 0. Why do you need that neuron? So this basically helps bypass these unused neurons that are zeroing out to really help increase the overall performance. So let's say if you're not using sparsity, you would still see a 10x jump over that of for FP32 at about 156 teraflops, you know, today, and that's again with no code change at all, and you know, by utilizing PyTorch and TensorFlow as the frameworks today that can help support it. And again, MXNet will be coming very soon. So a lot of, you know, performance capabilities with this new format, because basically what we're doing here is actually taking FP32 and actually truncating the mantissa to 10 bits and still using the same number of exponents, because you don't need all the precision within AI like you do with high performance computing, because it's a statistical issue. It's a yes or no problem. So you don't have to use all the precision, have the same or better accuracy using TF32 today. So huge innovation from a format perspective. Now, I talked about GPU partitioning and, you know, the capabilities of this, you know, this system. So now within A100, you can actually create up to 7 partitions, and these are fault isolated with quality of service partitions within the A100 itself. So in this example here, basically you would have 7 users with 5 gigabytes of high bandwidth memory each to be able to support different applications and deployment use cases. As you see on the left-hand side, someone's running TensorRT for an inference-based use case, where 2 users are running a TensorFlow job, and then 3 are using a Jupyter notebook, you know, let's say for an interactive session. And then the last person is running Amber from an HPC standpoint. So really just carving up these systems to increase utilization is key, especially if you're looking at TCO and an ROI factor that needs to be presented to the executives that place the capital expenditure. So really when you're looking at how you deploy this and scale these types of opportunities, is really enabling all lines of business and users that need to get access to these systems without having to worry about the plumbing in the background. And typically, data scientists, researchers really don't care about this. They just need to get access to get their work done. And so we've made it a lot easier for system administration and DevOps to really help deploy this. So for example, you can do these 7 partitions, or you can do 3 partitions with 10 gigabytes of high bandwidth memory each, or 2 with 20, because initially what we saw was, depending on if you're crunching images versus numbers, not a lot of usage of, let's say, full utilization of the V100 in the past. And so really kind of, being able to break these down per workload basis via an operator where the user can select this, makes this tremendously easier. So what this means is, today, you can do this with the CLI and NVIDIA Docker, and you can actually pin this per GPUs within the system per user. The evolution of this is, one, we're going to have Kubernetes support upstream within the July timeframe. Second half of this year, we're working with Slurm, OpenShift, but as well Rail 8.2 KVM, to help support these options and, let's say, different levels of orchestration tools and schedulers that can be utilized to the best benefit of the system. So when you're thinking from a performance perspective, this is a amazing way to increase the utilization of the system and still maintain better performance than you would get with a V100 today. And in the past, there's been software methodologies which are more temporal based and time oriented, and you see a lot of collisions of users' jobs or jobs dying, specifically because they're not getting the resources allocated for the job that was executed. So now we're able to do this from a hardware perspective to enable the orchestration tools and scheduling tools that we're familiar with, to really take advantage of this and execute on the system. So again, Kubernetes in the July timeframe, Slurm, KVM, with that Rail 8.2 and OpenShift second half of this year, for support. These are, again, major capabilities that, again, reduce the burden on a system admin having to do this manually, to allow the orchestration tools in place today to take advantage of it. So really key, with deploying this. And here's another example. We actually did this internally as a test case to run these, concurrently. But for example, DGX A100 is equal to, let's say, 56 users. And I talked about this a second ago. Was really where if you're going to dedicate or have a dedicated resource, a truly dedicated resource in the past, you would have to use roughly 7 DGX1 equivalents, to the DGX A100 to reach that. So that's looking at roughly $1 million versus something that's $250,000 to deploy. So having 2/3, of the cost removed, while you're able to enable all these users to get access to GPUs. And what this is showing here, all the different use cases. So whether it's a Jupyter notebook, a batch training job with NGC, or inference as they're colored throughout this map here. And what this is showing is 8 of these GPUs left to right and what they're being utilized for within it. And so for example, you can have all 7 of these slices be carved up to, say, different Jupyter notebook for interactive sessions, or batch training for ML-based use cases, or inference production, depending on how you're deploying and where inference is for you. So really helping increase utilization and deployment methodologies on how you carve these systems up. And so here's another example from a DGX workload perspective. Is one, you have 4 of these A100s in training mode. Then you would have 2 of these within, let's say, doing a data analytics job. And then you can take 2 of these and carve up 14 inference servers that can be served out for production use cases. So really helping with the utilization, removing the spikiness that you could have seen in the past to help improve stabilization of environments, and especially being able to scale these as you grow. And so this makes it easier when you're deploying of how and better, let's say, have better predictability of what infrastructure you need at what time. And so we talked about, all these different feature sets, and, really we got to talk a little bit about, some of this matched scalability, with the MELLANOX networking that's built within the system. So I mentioned earlier, you have 8 200 gigabit ports within the GPU complex, right? And these are dedicated 1-to-1 per A100 itself. And specifically, this, we call these cluster networking. This is where you tie all the compute together, whether you're using Rocky version 2 or IB, to bridge these. Again, all these are Ethernet or IB, but at the end of the day, when you're looking at scale and performance, IB probably gives you the best performance in using things like Sharp version 2 to really help accelerate that. But even from a Rocky version 2 perspective, being able to support pre-existing, environments and have that available, these are things that these cards help support today. Even from a storage, networking point of view, where you may be pulling from a NAS that's, gigabit E, or you have a parallel file system that's IB, you have 2 dual port based cards that, again, can be utilized for this effort. This card here actually comes with the system. This card here actually is an additional option. So you can actually add this if you need additional I/O within a network where you're doing fault tolerance based, deployments, where you're bonding the NICs. Oops, sorry. But as well, you have all your traditional things here. You have your BMC, but as well, the LAN, capability, which is LAN capability is really just the in-band management for controlling the OS within the system. And then as well, you have your VGA and serial ports that you can utilize as well. So a lot of capabilities, a lot of things that we've put here, even from a system perspective. Yeah, it's 6.5 kW. We have N+N redundancy from a power supply deployment scenario. So if you need to cable to PDUs on each side of the rear of the rack, to help with that, that is what we're doing today. So you can have up to 3 of those fail and still continue operations. So, so again, when you're thinking about building out these in pods, I'll show you in the next slide, but really what we recommend is typically for these systems, within a rack, and utilizing the MELLANOX quantum switch, which is a 40-port 200 gigabit IB, really helps with this because it actually fits the exact number of ports that would be required for a very simple fat tree deployment. So really interesting ways that we can deploy these systems, and I'll talk about some of the things NVIDIA is doing as well. So talked about this, what does workload performance, look like? So when you're talking about BERT or NLP use cases, right? BERT has roughly 340 million parameters associated with it. The more parameters you have with an NLP workload, the more compute processes you actually need. So, and especially getting it trained within a relatively good time frame. So what this is showing here is 6x the performance with DGX A100 for BERT, and having that over a single DGX1 using 8 V100s in the past. So really getting a 6x jump here. And then from an inference point of view, where you may have, a dual socket, CPU server, we're now getting, 172x that, right, with the DGX A100. So really, from an inference standpoint, really blowing out the performance numbers up to 10 petaops with the DGX itself. And then DGX1 here, this A100 for analytics and PageRank, this is basically showing 4 of these DGX A100s versus 3,000 CPU servers, excuse me. So getting a 13x improvement there with obviously, removing lots of costs associated. So when you think about the system, very flexible for utilization, capabilities and to help increase that utilization within the system, less power and, getting a hell of a lot of performance depending on, the workloads that are, being driven today within your environment. So a couple things that we wanted to build in, to this system, make it a little more enterprise aware, especially with cybersecurity risk, is what we call secure AI. And basically, this is a CEC chip that's on the board that one checks for the firmware, BIOS, and vBIOS, ensures that it's all NVIDIA science software before it boots. And so again, this helps from a cybersecurity model for, let's say, customers to absorb this within their environment or build around it, depending on where they're at today. But again, this is enabled, by default, but also can be disabled if needed. But having these on and helping with secure checks are key, and especially if you're doing a lot of web-based analytics and deployments. So with that said, elastic, AI infrastructure is really just kind of where we're, applying this with the DGX A100, where you may have been optimal with, a training cluster, and in different days, maybe you're associated where you're over that with an analytics cluster or under with an inference, a inference cluster, for example. So you'd see spikiness before, and then now have a better utilization standpoint. But again, the infrastructure is agile for you to be able to deploy, depending on requirements on different times of day, throughout the week, next month, etc. So these are ways that you can go and deploy these at scale and have support for multiple workloads and use cases. So again, this is actually showing some real benchmarks that we had made pretty here, from before, where we had separate clusters, right? You can notice the spikiness, associated with training versus inference and analytics on different days, and then afterwards, having a combined state, combining these with DGX A100, it really helps with the target utilization standpoint of 80%. So now you have better predictability as you probably inch closer to 100% of when you need to buy a new system to help support these types of infrastructures. So when you think about other examples, say, of how you could utilize it as well, as one DGX A100 is delivering 5 petaflops of AI training power, or 10 petaops of AI inference. So with multi-instance GPU that I talked about, a team of 25 developers can share that whole DGX A100. So if you compared that to, let's say, basically, over 180 teraflops for AI training equals, 2 reserved V100, cloud instances, or 357 teraops for inference, which is again equivalent to 6 of these dedicated 28 dual core CPU systems. So really just kind of showing a performance standpoint and being able to have this per user, and from 25 developers within one system versus having 2 each per developer in a reserve instance in the cloud, really is a cost benefit when you look at those numbers today. So very much dependent on how you deploy, how you accelerate, but really helping customers from a trusted advisor standpoint is really where we come from to help them make the choices that they need, depending on however they consume GPUs. A lot of that we do that with Mark III, for example, who is an excellent partner on helping decipher where we go and how we place these within customers to help satisfy needs and requirements. So we talked about pod development and where we're going. Typically, we're going to be starting up, with a 2 and a 4 node. Basically, the 2 node DGX pod will be showing how you scale to a 4 node, and this 4 node will show how you scale to an 8 node, from a building block approach. So not having to start, with 4 initially, you might want to start with 2 and see how you can scale these environments as you grow. So again, we're working on today, all the pod infrastructure and workload validation across these with all of our storage partners and networking partners that are out there as well, obviously including MELLANOX, who's now part of NVIDIA. But really utilizing these with NetApp, Pure, from a NAS standpoint, parallel file system standpoint, looking at DDN Lustre file system, as well as IBM Spectrum Scale, and how you scale these and build these types of RA designs. And one I forgot to mention, I'm sorry for those, but Dell EMC Isilon as well will have RAs, surrounding, all of these with these different architecture approaches. So really helping simplify the overall process on, what is needed for an AI infrastructure, and then how you go deploy this at scale. And one thing that we did come out with, in particular, which is our NVIDIA DGX SuperPod with the DGX A100. We basically have created a 140 node based system today, using a fat tree of 200 gig HDR switches, combining the system into a single cohesive cluster, using 4 petabytes of DDN Lustre file system. So really being able to leverage, this across these large scale environments and be able to produce a heck of a lot of performance that you would see from an AI point of view. So our previous SuperPod was 96 DGX2s, which was number 20 on the top 500 list. This system will probably be a top 10 contender as we go through. So some customers ask, well, I don't need 140 nodes. How do I scale? So we have building blocks to show how you go from that 2 node to 4 to 8 to 20 to 40 to all the way up to 140 to help support any needs and requirements to accelerate scale and building out the performance capabilities from all of the knowledge that we maintain internally. So all that's shared with all of our DGX customers and how you build this, and we can help support different needs and different requirements. So one thing that's really exciting that came with the launch is, one, we worked with Argonne National Laboratory to be our first customer. So this is the first DGX A100 supercomputer helping fight COVID-19. So this is a 24 node cluster of these DGX A100 systems, and utilizing HDR-IB within this as well. So getting a lot of performance for all these very scientific workloads to really help fight something that's keeping us all at home today. So again, this is a huge advancement, and working with them has been tremendous. Great, customer and partner, throughout this deployment. And something to note, I just want to show kind of what our scales look like over time. So from March 2016 was the first DGX1 that we built, and that was again around P100, and then we upgraded it to the V100 as it came out. Then November timeframe, our DGX SATURNV, which was initial install was 125 node cluster, and was number 28 on the top 500 list. And then December we expanded it to 350 nodes, with NGC deployed on all of it, and then expansion to 1,000 nodes in September of 2018. Then we launched the DGX2, which is the 2 petaflop system, and we expanded the SATURNV, which is our internal cluster, up to 1,400 nodes, and Circe, which is a 36 node DGX SuperPod, which is number 78 on the top 500 list still today. But then in June, we expanded that environment to up to 1,800 nodes, and then that 96 node DGX SuperPod, which was number 22, then now number 20 in November. And with DGX A100 and the Selene, we're up to 2,000 nodes internally, deployed for internal maintenance and internal software development and deployment mechanisms to help make AI easier for our customers, but as well as showing how we can highlight the latest technology in a high performant environment. So really, we like to stay in front of the game and really build out a lot of these performance capabilities. All the software and enhancements from a DGX point of view all come from all the stuff we work on internally today, especially highlighting how we build performance containers, which are all built on DGX, that are all within NGC, and you would get that performance inherently derivative of those containers that are deployed on our system. So really being able to use the full ecosystem from NVIDIA really does help from a benefit of a perspective of performance, but as well being able to utilize these techniques for deploying AI, whether you're starting with a 1-2 node cluster to building that out all the way up to 140 node environment, or in some cases a 2,000 node environment, like we have internally. We have customers that have standardized on DGX and really moving forward with it. So with that said, we have what we call DGXpert. So these are a bunch of DGX experts. So we have roughly 14,000 DGX experts with internal to NVIDIA. So no matter what your problem is, whether it's designing, planning, building, testing, deploying, operating, or monitoring, we have best practices that we've built around this, and we have basically, you have NVIDIA's 14,000 engineers at your disposal to help support your ongoing infrastructure of how you go deploy these AI-based systems. So again, these are all ways that we work with Mark III. They have the best practices. We have everything to help support them, as well as you, the customer. So a lot of capabilities here to help utilize the ecosystem that NVIDIA provides. And then lastly, kind of talking about, we have these, experts that are out there. We have the largest DGX, environment today, which is now roughly 5 exaflops of performance internally to NVIDIA that's being used. But again, full stack solutions, for you to use for all your data algorithms, models, and compute, storage, and networking, et cetera, to really help drive what you need to get done today. So really broadening the ecosystem to help support everything that you have and how we can help you from a performance standpoint. So, with that said, a lot of information here today, but go out there and check out some of the resources that are available. Call Mark III. These guys are experts as well of helping you talk through where you want to go and how you want to deploy and supporting what you're doing today. So really that kind of concludes the overall presentation. But I guess Andy, we can open this up for Q&A now if we need to.
Awesome. Yeah, if you guys have questions, feel free to put a question in the Q&A box, or you can, I believe, message us directly and we can open it up. I've got a question in the meantime, Will. I know we're working with a lot of different clients specifically around orchestration strategies. I think it's particularly relevant with the multi-instance GPU feature, which I think in my opinion, it's one of the most powerful features in this release, let alone the 20x and all those amazing performance numbers. Can you talk a little bit more? I know you mentioned Kubernetes, Slurm. Can you add a little bit more color as to what those considerations are? Because I think that's something that a lot of folks are thinking about, but the paradigm may or may not be shifting with the A100 just because of that feature.
Yeah. So again, supporting all these different functionalities, right, are key for how we're deploying this. So Kubernetes will be first, Slurm, OpenShift, KVM second half of the year, sometime next year, VMware vSphere even, right? But really, what it comes down to is how do you want to iterate faster? How do you want to perform faster? How do you deploy these things at scale? So typically for shared environments, the obvious go-to is Kubernetes. Mainly from an orchestration standpoint. A lot of things have been simplified in the past, and a lot of people have heartburn from it in the past of deploying. But specifically, a lot of improvements have been done here, with Kubernetes as well as software instances, supporting whether it's Branch or OpenShift, others that are in the environment, or even Bright Computing, for example, that could go deploy this, effectively and easily. The key is really understanding how you're sharing the infrastructure and building it out. Even from a Slurm perspective, when you're needing to scale up GPUs, meaning that you have a single job with a multi-node initiative, that's typically where Slurm comes in as the best performant today, and really helps with that bare metal performance that you expect. So really, Slurm from a scheduling perspective, we've done a lot of innovation there, where we have enroute and Pixis, which help with independent sandboxing of nodes, and really supporting how you're deploying code across. But really, if you're looking at heavy iterations and deployment and ease of use of deployment, Kubernetes strives far above most, as well as using tools like Kubeflow and partners that are out there that support it. And we've actually vetted 5 of these, to help with the end-to-end use case, where the top 3 in my mind are Iguazio, Converge.io, Domino, but we also Paperspace if you're managing from a cloud control plane, or deploying within IVR use cases as well. So just very much dependent on how you're deploying, but those are some of the characteristics that majority of our customers go through, if that helps.
Awesome. Yeah, very helpful. Does anyone out there have any questions? All right. All right. Well, thank you again for your time, Will, and thank you for everyone for joining today. If you have questions after the fact, feel free to reach out to anyone on the Mark III team, and Will as well. But like I said, thank you again, and look forward to.
Yeah, thanks, Andy. Thanks for having me.
Absolutely. Thank you, guys.
All right. Thank you so much.